Hi, welcome back. So in the last video, I showed you how to work with abstraction. So in that video, we saw how the data that you are storing or you are accessing is directly stored in a class securely and safely, and then using specific functions like this one or this one or this one, we can directly call the data, or we can directly call the code. So instead of writing everything in the front end, we just use the methods or functionalities from the class, right? So this is nice, this is actually good. Let me explain in a different scenario. For example, we have a game. Okay, I'm making a game. In that game, I have two players. Let's say chess game. Okay, in a chess game, there are two players, and there are how many? Two horses, two bishops, two rooks, and one queen and one king. And then 8, 9, 10. So then we have 10, I think. How many? 1, 2, 3, 4, 5, 6, 7, 8. 8 squares. Yeah, 8 into 8. Yes, exactly. 8 squares. So there are 8 pawns on one side, right? Two horses, two bishops, two rooks. Yeah, two horses, two bishops, two rooks, one queen, one king. So that's 8 pawns. Totally 8 plus 16 pieces on one side and another 16 pieces on another side. So there are like, if you want to code this, if you want to write a program for this, you need to write the same program for both horses, for both bishops, for both rooks, for both sides queens and both side kings and both side pawns. So you need to write the program multiple times. So for example, in this case, there are two horses on white, two horses on black. So there are four horses, four bishops, four rooks, two queens, two kings, and 16 pawns. In this case, you need to write the same program that is written for one horse for multiple horses, or you need to write the same program for multiple bishops, or maybe you have some takedown mechanics, or you can say some movement mechanics, which are similar to pawns and also similar to kings. So for example, pawn moves one step forward, king also moves one step forward, queen also can move one step forward, rook also can move one step forward, but bishops and horses can't move one step forward. So in that case, when you have some kind of functionalities similar to like similar in most of the pieces, when you have similar functionalities in similar pieces, you need to use inheritance. I already explained that, right? So for example, what can I do here? I will say movement, or let's just say we have a pawn class. Okay, so the pawn class will have movement. So the movement, the way they move, the movement logic will be similar to the king class, the queen class, and rook's class. Similar. I'm not saying same, I'm saying similar. Then queen also has the similar pattern like a bishop. Queen also can move diagonally. Queen also can move like a rook. But queen can't move like a horse. So when you want to create some kind of program like this, you need to understand one thing. Some programs are written specifically for one class. For example, in this case, I wrote the program called cart, right? I said show bill, show items, add item, remove item. All of these programs are written specifically for the cart. I can't use this show bill in let's say item manager. Why? Because item manager is displaying the items, it is not creating the bills. So there are specific programs written for specific classes. But what if I want to show the same get item in item manager as well as in cart? So show item is also in item manager as well as in cart. In that case, what should I do? So when I want to create two like similar functionalities, what do I do is I just write one class, I write the functionality within the class, and then I inherit that class to both cart as well as item manager. This way we don't need to write the code. Since the class already has that code, it is already inherited directly into this class. You understand? What I'm trying to say here is, for example, show bill has the function called show items. Okay, let's make it a public function. So show bill, I mean cart has a function called show items. Let's say show items. So cart has a function called show items. What if I want to do the same thing in iManager class? Show items. Now I need to write the code again? No, I just create a separate class and then I write this show items function within that class and extend that function, extend that class to cart as well as item manager. So by doing this, what I'm doing here is I am not writing the program again. I'm just extending the program. This is called inheritance, right? Sharing the properties, sharing the code. So inheritance is a way to use one property of a class into another property of another class. For example, the movement vector, the way the pawn is moving, is similar to king. So instead of writing the same code again in the king class, I'll simply say extends pawn. Of course, it is not a pawn, but I'm just saying, just to get this movement code, I'm writing extends pawn. Now, as I said, king is not a pawn. King is the king, the topmost important piece that you need to defend in a chess. Now, the problem here is, whatever the code you're writing for this pawn will now be used directly inside the king. So now, king also behave like a pawn. But king is not a pawn. As I said, king is the topmost piece. So how do you avoid using the pawn's properties in king's class, but simultaneously using this movement code in king's class? Also, one more example. Queen also has a diagonal movement, which means queen also can move like a bishop. So how do you prevent the bishop's properties from entering into queen's class? If you're talking about king class, king is a different object. Pawn is a different object. By extending it, by extending pawn into king or king into pawn, we are extending one class's entire properties into other class. There is a problem with this. For example, if I extend this property, this is kind of acceptable. What if I do the other way? What if I do the reverse way? King has all the properties. Now I say extends pawn. Now what happens? So, sorry, kings extends king. Now what happens? Now the chess piece will behave like a king. Although it is not in the, although even before the game started, as soon as one pawn dies, your game ends. Because the king logic is working in pawn. So in this case, to avoid confusions, we create specific interfaces. Okay, we create interfaces. What are these interfaces? Interfaces are like carriers. They are like optional carriers. They carry the options, they carry the functionalities. Instead of copying each and every class into each and every class, instead of extending each and every class, we simply implement the code. How do we do that? For example, bishops and rooks, those two can be extended into queen, because queen behaves like a bishop as well as a rook. So in this case, instead of copying the code or extending the code, I will simply implement bishop movement and uh, rook movement. What do I mean by this? Bishop movement, rook movement. What do I mean by this? I mean, when I say implements bishop movement, rook movement, I am simply moving the queen as a bishop or as a rook. I am not inheriting everything from the rook or everything from the bishop. I am simply saying queen is a queen, but it can move like a bishop or move like a rook. Okay, the same thing I'm doing here. I'm simply saying implements pawn movement. Now, what happens in the king? King doesn't become a pawn, or the pawn doesn't become a king. It simply becomes a pawn movement, which means the way the pawn moves, king will imitate it. King doesn't become a pawn, okay? Or in the reverse way, pawn doesn't become a king. Now, we are simply carrying the movement code in this interface. So wherever you write this interface, wherever you implement this interface, that interface code will now be applicable to that class. This is how we use interfaces. And to say that it is an interface, and to define that it is an interface, we write an I in front of it. This means interface. I rook movement, I pawn movement. Okay, so instead of writing everything from instead of writing each and every code in each and every class, or extending the code and then struggling to like create a program where everything is working, instead of doing all that spaghetti code nonsense, we can create interfaces and we can implement the program in this way. Now, let's say we have a pawn interface, pawn movement class, I pawn movement. Okay, in this interface, what do we have? We have a move like a pawn, like move one step. So how do we say that? Public void move one step. This is a function. Move one step, or you can say move a step. Okay, move step. So how many steps the pawn is going to move? Only one. So we'll say the move one step will move only one step. What if I want to create multiple interfaces? You can do the same thing for bishop and rook by just creating multiple interfaces. Interface I pawn movement, move steps, like that. So now whenever I use this, for example, this is a class pawn, I will say implements I pawn movement. Now automatically this move step will be used here. Instead of movement, I will write the program for the move step. Now, the same move step can now be also implemented into king, I pawn movement. Okay, or you can also take this even one more step further. You can also say this is a pawn movement class which implements I pawn movement, and then you create the pawn class like this. Class pawn extends pawn movement, okay, and king also extends pawn movement. You're not extending the pawn code, you're extending the pawn movement code. King doesn't become a pawn this case. King becomes the king. King will stay as the king, but the movement it takes will be similar to the pawn. Same thing you can also do for the bishop movement, rook movement. Okay, what I'm explaining here is I'm trying to say that when you are writing programs, some programs need to be reused. Some programs must be re-given or reused, executed. In that case, instead of copying each and every program from each and every class, instead of saying extends everything, I'll just simply pass the behaviors as a interface. Now, what is an interface? Interface is like a class. It is like a class. But instead of creating entire object blueprints, we are creating behaviors. Okay? Instead of saying like this, instead of saying class bishop, we say interface I bishop movement. Interface bishop movement. So in this case, what is the bishop movement? The bishop moves in a diagonal way. So I'm saying public void move diagonal. Okay. So when I say move diagonal, it always moves diagonally. This is bishop movement. Now, if you write the code for this, for example, say class queen, okay, implements I bishop movement. It implements the bishop movement. The same thing you can also do for the bishop, actual bishop. So bishop implements I bishop movement. So in this case, we are not actually copying the code from bishop into queen. Queen doesn't become a bishop. Queen is queen, bishop is bishop. But the movement, the way they move will be copied. The way they move will be same. So this way you can keep the identity of that object, but you can also copy the behavior of another object. By keeping the identity, the object doesn't become another object. It becomes its own unique entity. But you can also copy the movement of another class into this class by using interfaces. So interfaces are a concept of abstraction where you are abstracting the behavior, especially the behavior of one class, and then sharing it with other classes. This is called interfaces. Okay, whenever I create interfaces, it means I'm abstracting the behavior of one class and trying to apply this into other classes. This is a way to teach programming to kids. By creating chess, you can also create programs. You can also learn programming by creating chess games. There are many types of chess games. You can create lots of different types of textures. You can create lots of different types of animations, sound effects, all that. You can make your own chess pieces, right? The logic is similar, the programming is also similar, but the visual can be different. So you can try something like this. Okay, there are many GitHub projects that explains how to create chess. You can see that and you can learn. In that also the same thing. We have movement interfaces. There are interfaces that mimics the movement, that shares the movement from one class to another class. So what is the purpose of interface? Interface is an abstraction, is a process of abstracting the behavior. Instead of writing the program, instead of extending the class itself, we are extending the behavior. Okay. Now, what is the use of this implements or extends? Why do we need to use these extends or implements? Well, let's say, let's take another example. Let's take another example here. So this is one example where we have different classes with different behaviors. I mean, similar behaviors, but different functionalities. So queen moves in a bishop movement, and also we have rook movement. So if I have rook movement class, I'll also implement the rook movement class. So now queen can use both types of programs. Queen can move in both ways. Now, we know that there are programs which have this kind of implementation where we have similar behaviors between different objects. What if there are multiple types of objects with similar behaviors? For example, you all have played PUBG, right? Or you have seen PUBG, something similar to PUBG. For example, you have seen COD, Call of Duty, or you might have seen Free Fire, or any other game that has FPS mechanics. So in those games, or you can say RPG as well. For example, in RuneScape, Albion Online, or Guild Wars 2, any other RPG that you played, you have weapons, right? For example, in PUBG, we have weapons. For example, say SMG, LMG, snipers. We have shotguns, right? When I move, or I can also have pistols as well. So, for example, I picked up an SMG. SMG has a short range, but it's a burst ability, like Uzi. So it's a SMG. Pistols, they are also short range, but they are individual. What do you call this? Single shot. Okay. LMG are long range machine guns, whereas snipers are bolt actions. So single shot, long range guns. Shotguns are again short range but burst damage. So in this case, different types of weapons have different types of functionalities, but when the player pick them up and you press a button like a mouse click, in the front end it only says player dot shoot. Okay, it only says player dot shoot. Now what happens behind the shoot? What happens behind this function? Or let's say player dot attack. What happens behind this function? I have an SMG, I have a pistol, I have a sniper, I have a shotgun. How does the game knows what weapon you have or what weapon type you have? If I'm using a pistol, for example, say player dot equipped weapon equal to let's say pistol. Okay, now if I'm using pistol, the attack damage will be low. And let's take a target here. Let's say player 2. This is player 1 and I'm attacking player 2. So the attack damage will be low, and unless the player 2 is closer to you, the damage will be even lower. So if they are in range, the damage will be high. If they are out of range, the damage will be low. So how does the system knows the range, the damage, the defense, all of that? How does the system knows all of this? Well, that is the abstraction that I explained yesterday. We don't show the program to the front end. The front end doesn't care what you are using. That means the client that you are using, let's say you are playing PUBG, right? You're playing a match in PUBG. Your client doesn't know what you are holding. Your client only knows to attack. Your client will send a message to server that player wants to attack. That's all. The client doesn't know what you are holding. The client doesn't know what type of weapon you are having, how many bullets you have. The client doesn't know anything. All of that information is in the server. So when the client says attack player 2, automatically the server will calculate the damage and the server will show the required damage to the client. The client will then update the UI. Understand? So this is what I'm talking about in abstraction. Abstraction, we have two clients, we have two things we call client and server. So the server has all the things. Server has all the data, all the programs. Client just calls the function move, crouch, jump, pick, all of that. Pick, drop, everything is just functions. When you pick up a weapon, it is not necessary to be equipped, or maybe not necessary to be currently equipped. For example, you can also swap weapons in PUBG, right? Let's say you have gun 1 and gun 2. In gun 1, let's say in public equipped weapon 1 is pistol. Player 1 dot equipped weapon 2 is let's say weapon 2 is SMG. So in this case, which weapon you are equipping, no one knows. The client doesn't know. The client only knows that you pressed attack. That's all. The server will figure out which one you are holding right now, which one is active, and then it will use that weapon's damage as the base damage, and then the player 2's defense, armor and everything that's negated, and then the final damage is shown. So this way, all of that like programming mumbo jumbo, all of that thing is in the back end. Nothing shows in the front end. This is abstraction. This is the power of abstraction. Now, the problem here is when I say SMG, when I say pistol, when I say LMG, when I say sniper, when I say shotgun, all of these have different types of effects. SMG has burst, pistol have single shot, LMG have burst again, sniper have single shot, bolt action, shotgun also have bolt action, but it is burst bolt action. It's like a spread, right? So each and every program is different. Each and every functionality is different. Each and every code is different. How does the program knows that when I press attack, that I need to use SMG's attack, I need to use pistol's attack, or if I'm using LMG attack, how does the backend knows all that? So for that, what we do is there are two ways. One, we can use a switch case. The switch case is like this: player dot current weapon. So right now, which weapon is active? Current weapon is like this. Case LMG. If it is LMG, then we use LMG dot shoot. Okay. Or in case if you are using SMG shotgun, then we use shotgun dot shoot. Right, we write the program individually for different classes, and then we call the shoot function, or we say LMG dot burst and shotgun dot shoot, or you can say shot fire. Like, so you can also add a flamethrower that can shoot fire, like that. So when you are writing programs in this way, there are two ways. As I said, this is the first way, using switch case or if conditions, if else. There is another way. Another way is using interfaces. Let me show you that. So I'll create an interface like this. Interface I weapon. Okay. Every weapon will have this interface. What is the interface? Public void shoot. Now I'll give target here. I'll say game character target. Okay. So when I say I weapon shoot, now I create a class. I'll create a class like this, class shotgun. I'll say implements I weapon. So automatically this shotgun becomes a weapon. It has the shoot code. If I use class SMG, I'll say implements shoot. Implements I weapon. So again, this SMG also becomes a weapon. The same way, if I have a log, let's say wood log, I'm carrying a wood log, implements I weapon. So automatically the wood log can be used as a weapon. I can use it to bash like a pan. Okay, like a wooden, like a pan, fry pan. Fry pan implements I weapon. So automatically it also becomes a weapon. Now, if you writing a code for the shotgun, shotgun has a different animation, different code, different behavior, but the shoot function is same. SMG also has a different code, different behavior, different animation, but the shoot function is same. Wood log and frying pan all have different animations and different code, but the shoot function is also same. So when I say player dot attack, or in case I say player dot shoot, what I'm saying, I'm simply just calling whichever weapon is there, like this, player dot current weapon dot shoot. Now when I say player one dot current weapon dot shoot, the client doesn't know which weapon is the currently equipped weapon. We have two weapons here, equip 1, equip 2. Which one is current weapon? We don't know. Client also don't know. Server knows because the data is in the server. Server will find out which weapon we are currently equipping and then use that shoot function from that current weapon. So if the current weapon is SMG, it uses the SMG's shoot function. If I am using frying pan, the current weapon is frying pan, it will use the shoot function from the frying pan. So the same functionality is now used in different classes. This is called overriding. Okay, same functionality, different class, different behavior. Same function, different class, different behavior. This is called overriding. So when I want to write the program for this, I need to override this function. By overriding the function, I'll simply just say player.currentWeapon.shoot. Now whichever current weapon is I'm using, that class's function will execute. That class function will execute. Understood? This is how overloading and overriding works. So what is overloading? For example, I said wood log. Now wood log can also be used to fire, like burn something, or you can also use it as a bash weapon. For example, in games like Albion Online or RuneScape, you can use the wood log, and you can also refine it, or you can sell it. But for example, in case of games like Guild Wars 2, if you have played Guild Wars 2 or any other games that have similar functionalities like World of Warcraft as well, if you pick up a wood log, you can use it as a weapon, as a bash weapon, or you can also like use it to craft something, right? You can use it to craft some other weapon, or you can use the wood log as a bash weapon. So either you can craft or you can bash. How do we do that? So we say comma I craftable. So when I say I craftable, automatically the wood log can now be crafted into some other thing. For example, I can craft the wood log into furniture. For example, in Stardew Valley, if you have played the Stardew Valley, or if you have seen Animal Crossing, RuneScape, those kind of things, when you build something, you create this, you use this wood log to fight, to throw onto an enemy. So if you throw wood log, the wood log behaves like a throwing weapon, right? So in this case, it becomes a weapon. Or you can also use the wood log to craft something like a furniture, a bed, a desk, a table, right? A boat. So you can also use the wood log to craft something or as a weapon. This is what I'm saying. When you are using behaviors from different classes, we can simply extract the behavior into an interface, and then we use that behavior for different classes. Instead of extending same class into different class, you can use the behavior of same class into different class. This way, what happens is, what happens here is, instead of shotgun becoming an SMG, or SMG becoming a wood log, or wood log becoming a fry pan, they become a weapon. They remain a weapon, but the functionality changes. Okay, so when you are writing the code in this way, you use polymorphism in this way. Overloading, overriding is this. Overloading means same class or same object can behave in two different ways. For example, here I said wood log can be used as a weapon or can be crafted into other things. This is called overloading. And overriding means you can use the same functionality of one class and override it into another class. So in the SMG, the weapon behaves differently, the shotgun, the weapon behaves differently, the wood log behaves differently, the frying pan behaves differently. Okay, this is called as polymorphism. This concept is very important when you're writing games or apps or websites, because this is the code that that simplifies your program. It is like flexibility. It provides flexibility to your code. Instead of writing lengthy if else's or switch cases, you simply use interface. Okay, now what if I don't want to use interface? I don't want to use interface. I want to write the program in the class itself. Well, in that case, we have abstract classes. Abstract class, let's say demo1. This one will have a abstract function. As I said, abstract basically means the essential function. The essential function for all of these weapons is shoot. Right, the essential function for all of these weapons is this, shoot. Every weapon must be able to shoot. So this is the essential function. So if a class has an abstract function like this, abstract void shoot, then in that case this class becomes abstract class. Okay, it's just straightforward thing. And abstract class behaves as a base class. It cannot be used as a object. It must be inherited. So yeah, instead of writing code individually, you can also write a class and call it directly. Or if you are if you like feel like you want to write the code individually, you can write code individual interfaces. Okay, so this is polymorphism. Now let's see how this program works. Let's create a class here. Okay, PCK5 polymorphism demo. In this polymorphism demo, what I'm going to do is, first of all, let me close all, save. Okay, is there nothing? So in the polymorphism demo, let's create main function. And in this main function, what I'm going to do is, I'm going to create a player class. Okay, player equal to new player. Now, when I say player dot attack, okay, so I don't want to use that. I don't want to use this. I'm saying player dot attack. Let's take a monster. Let's say goblin. Goblin G equal to new goblin. This is the monster. Okay, this is the monster class. So I'm saying player dot attack G. And now I simply just want to create the code. So what do I do? Let's close this and let's create some new classes here. So in the player class, it simply has a constructor here. First of all, we say constructor this, and for this I'm going to create some private variables. Private int health. You can also create health, minimum health, max health, like that. Private int attack. And instead of doing all that, we can create a class called game character and write the code in that game character class. So game character class will have all the functionalities. So I'll say private string name, private int health, private int attack, and private int defense. So here we'll say game character, okay, string name, I'm giving string name first, then int health. Okay, let's just drop everything here itself. This dot name equal to name, this dot health equal to 100, this dot attack, this dot attack equal to let's give 5, this dot defense equal to 2. Okay, every game character will have this. Then we need to add the source getter setters. So just select getters and generate, and we have the getters. Okay, so now this game character can be extended to the player. Extends game character. Of course, this is requires a function here, constructor. So the constructor will have a name. So I'll just simply use a name. Here I'll simply pass my name, Suman. Or let's give a name like Arthas. Now I need another character called Goblin. So I'm going to create a class called Goblin class. And this Goblin class also extends game character. And in the Goblin, we're going to pass the data. So instead of sending here like this, we directly say Goblin or Gobi. Okay. Now, when I say extends, it means it directly executes everything from this class, directly from this class. Okay. Now, when I say player.attack G, what I'm saying here is I'm trying to say attack the Goblin. So what do I do? Public void attack game character G. So first of all, we need to find the damage. So int damage equal to the damage that I have, attack, okay, plus the player also will have a, let's say, private weapon, equipped weapon. I'm just giving one weapon. I'm not trying to create right now. I'm not trying to show you anything. Let's give weapon 1, w1. Okay, so when I say attack plus w1 dot get attack or get damage, w1 dot get damage, so both of this will then g dot get defense. Yeah, so both of this will be negated from the defense. Now, if this damage, if this part works, which is this, I need to negate the damage, right? So take the Gobi defense and then negate the damage from here. Right. What if the defense is low, so that damage is high? So we need to just position this on the other side. So here the damage minus the Goblin defense. The final damage, which is if damage is greater than equal to 0, greater than 0, then we will see some defense, some health damage. Health minus equal to damage. Else health equal to let's say, what do we say? Instead of saying like this, I can give it in another way. I can give it a lambda function, or I can use a constructor like conditional operator. For example, say this one, int damage dmg equal to this, int final damage equal to, if dmg greater than 0, Then we'll send DMG or 0. We don't need to write any of this now. We simply say health minus equal to final damage. That's it. Okay, so here the code. First of all, we need a weapon class here. That is why there are so many errors here. Let's create a weapon class. Weapon class. The weapon class will have two things. First is we have a private string. I can also create weapon types and everything, but I'm just giving name. And then I have a private int damage. Okay, public weapon string name and int damage. So here I'm saying this dot name equal to name, this dot damage equal to damage. So first of all, I will say public int get damage, return damage, and public string get name, return name. Easy. So now we have a weapon. So the weapon will get the attack. Why are we using this? Game character. Yeah. So the game character doesn't have attack. It has attack. Oh, I can't directly use the attack. Okay. I directly can't use the attack because it is private, right? See, in this public class, it is private variables, so I can't use it. So we need to use get attack. Get attack dot get damage dot get defense. That's it. Now we need to set the health. So how do we set the health? We simply say set health of final damage, get health minus equal to minus final damage. This is set health. So set health will be here. Here it is. Public void set health int health. This dot health equal to health. Right. So now in this case we say set health. What is the problem? Health. H capital. Okay, any more problems here? No more problems. Done. Okay. Weapon done. This is done. This is done. Game character done, and this is also done. Now the problem here is how do we set this weapon? I said weapon damage, right? How do we set the weapon? So to set the weapon, we need to set a equip kind of thing. I'm going to do like this: public void equip. So here we pass the weapon, and this dot w1 equal to w. Whatever the weapon I equipped, it will pass it to w1. From there, I'm going to attack. So in the polymorphism demo, first of all, I said like this. Now I'm saying player dot equip new weapon. I'm passing as sword, comma 10. Okay. Now when I say attack G, I need to show the player. So sysout player and then system out goblin G. So to print the stats, we need to change the functionality of the toString, because right now if I execute this, you will see what this. If I execute this, you will see two objects. I want the object stats. So to do that, we need to override this toString function. What I'm going to do here is I'm going to create a string s equal to string.format Okay, what is the format I want to see here? I want to see the name first, name, which is %s string. Then I should see health or /n, health or HP, remaining HP, %d/n, weapon that I am carrying right now. The weapon, game character doesn't have weapon, so there is no weapon here. Just the name and HP. So name, comma, health. Okay, so return S. Now if I execute this, you will see that there is Arthas health 87, Gobi health 100. Right. Why did I why is it showing this when I say attack? Why did the character got attack? Because I wrote the code in that way. So I should say g dot set health, g dot get health minus final damage. Now you will see the damage to the goblin, not to the player. Okay, so what if I say g dot attack? See, there is no attack for the goblin. So what do I do now? So instead of writing this attack code, I'll just have to use an interface. What do? I create an interface here. I call this I attack. Okay, interface I attack. This one has a public void attack function. This function will have a game character class, game character G. Right. So now in this case, I just simply go to the main class, game character class, and I say implements I attack. Okay, so instead of, yeah, so here it is, attack. So instead of writing the same program multiple times, I simply just copy this program, cut this here, and paste it directly in the game character. See, @override. So it is overriding the code. So when I paste it here, now what happens is it will see there is a problem with the weapon damage. So there is no weapon for this class. What to do? So we can do in this way. Instead of adding the weapon in the player class, I'm going to add the weapon directly in the game character itself. Private weapon W1. Okay. Public weapon get weapon, and this is return W1, and public void set weapon, which weapon you want to set, that will be given here. So you simply say this dot W1 equal to W. Now in the player class, I'll simply, instead of saying like this, I'll simply say set weapon W. That's it. So when I say equip, it is actually going to the main character class. It is actually going to the code here. Now there will be another problem. The problem here is, let me show you that. The problem here is goblin does not have a weapon. So when goblin doesn't have a weapon, how does the game knows what is the weapon damage of the goblin? The weapon is there for the player as well as the goblin. But the goblin doesn't have a weapon. The player has a weapon. See? Player has an equip code. But goblin doesn't have an equip code. So what does the goblin do? In this case, what I'm going to do here is, in this attack code, where is that? In this code, what I'll do here is, I'll simply select this. If W1 equal to null. Okay. If it is equal to null, so what do? I will use a different code. So this one, let's cut this off, and I'll say int damage equal to 0 or int dmg equal to 0. So if the weapon doesn't exist, or if the weapon is not there, if the NPC doesn't have a weapon equal to null, then we'll simply just get the attack and minus defense. That's all. Okay. Else we'll say this, which will have damage. So weapon damage. If the weapon exists, then you get weapon damage, or else normal damage. So this is how we create the code. Now if I execute this program, you will see Arthur's getting hit for 97, but Gobby got hit for 87 because Arthur's has a weapon. Arthur's weapon is actually a sword that has extra 10 damage. So 10 damage for Arthur's, 10 damage from Arthur's. Why? What is the damage that I gave here in the game character? You can see it here. The damage that I gave here is 5. So 5 damage from the game character, 10 damage from the weapon, that is 15 damage. And what is the defense? 2. So 15 minus 2 is 13 damage is getting hit to the character. In case if you don't have a weapon, only 5 minus 2, 3 damage is hit to the character. This is why we are getting 97, but they are getting 87. Okay, so this is how we can create an interface. By using an interface, we can automate the code directly from any program. Okay, so by creating interfaces, we can reuse this program into multiple classes, multiple scenarios. Instead of writing the program multiple times, we just reuse this code multiple times. So now we can also use this same thing, same logic. Instead of writing it here, I can write the code in the player class separately and goblin separately, like this. I can say implements I attack. Okay, so now what happens is when I say I attack, automatically the goblin becomes a attackable target. So goblin can attack like that. Okay, so in this way you can write the code separately, but instead of writing the code multiple times, I just wrote the code once, like here. I just gave it like this. If there is no weapon, then directly just take the code, or if there is a weapon, then use the weapon damage. So instead of writing 2 codes, I just wrote one program and wrote the if else for that. Simple. This is abstraction. Okay, this is called abstraction. Abstraction is all about hiding the code in the backend and only using the required things. For example, here I said player, equip weapon, create a goblin character, attack. Player attack goblin, goblin attack player. That's all. Okay, so this is how the client works. Client doesn't know what the player is holding. Client doesn't know what the goblin is holding. Goblin is having any weapon or not. The client doesn't know. The client knows that player has an attack function, goblin has an attack function. That's all. Okay, whether they are related or not, the client doesn't know. The front end doesn't know whether they are the same class or different classes. Now, let me show you the difference between inheritance and non-inheritance. See, in Java we have a keyword called instance of. Okay, instance of. This is a keyword. It is used to check whether you are a part of the class or not. For example, I said player is instance of game character. Okay, if it is true, you get true. If it is false, you get false. It is true. Because why? Because player class is actually extending game character. That's why. So it is an instance of game character. Now, if I want to see if it is instance of interface or not, I said interfaces are like classes, right? Let's try. Is it a instance of iAttack? Let's see. True. Player has iAttack. Player has the interface. So as I said, interfaces are like classes, but only behaviors. Interface doesn't have any program. It only has behaviors. Class has all the behavior, all the classes, behaviors, functions, and everything. Okay. Class contains the data. The class contains all the variables and functions, but interfaces only has the functions, nothing else. This is the difference. So when I say instance of iAttack, it means there is an attack code. If I say instance of iWeapon, there is a weapon code. For example, there is a woodlog. Woodlog instance of iCraftable. So that means there is a craft code. The woodlog can be used to craft. If there is a iWeapon, that means there is a fire or attack code. So the woodlog can be used to attack, like that. Okay. So this is the beauty of using OOPS concepts. OOPS concepts is all about writing a program in a modular code, modular way. So I hope you understood all of this. Any more doubts you have, you can ask in the comment section. I'll explain the doubts. If you have any requests, or if you want to know any topic, you can also ask in the comment section. Okay. Thank you. Bye.